Let us solve a problem involving angle of elevation. An airplane flies at an altitude of 5 miles toward the point directly over an observer. The speed of the plane is 600 miles per hour. We are asked to find the rates at which the angle of elevation theta is changing when the angle is A 30 degrees, B 60 degrees, and C 75 degrees. So using the illustration given, let us label the point directly over the observer. So over the observer and along the path of the plane, let's label that point as point A. Now, from point A to the plane, let us use x to represent the distance between point A and the plane. And the given rate, which is 600 miles per hour, would now be represented as dx over dt. And this is going to be negative because as the plane moves towards point A, the value of x would be decreasing with respect to time. So we will be writing it as negative 600 miles per hour. Okay. Now, um, using properties for angles, we know that this angle here would also be theta, which is our angle of elevation. And then this side here, parallel to this side, will also be 5 miles because nothing in the problem states that the altitude of the airplane will be changing throughout time. So that would still be 5 miles. Now, we are required to look for the rate of at which the angle of elevation is changing. Now, if theta is the angle of elevation, then we represent our required rate as d theta over dt when we have three values for the angle. So when theta is 30, 60, and 75 degrees. Okay, so we proceed. Since the problem involves a relationship between an angle and the sides of a right triangle, we are going to use trigonometric expressions. In this case, it will be tangent because if you look at the triangle here, with respect to theta, we are given the adjacent and the opposite side. So the formula that we are going to use will be tangent of theta, and this is equal to the opposite side, the side opposite of theta, and that would be 5, and then over the side adjacent to theta, and that would be x. So this is now our working equation for this problem. Tangent theta is equal to 5 over x. So we continue. So let me write our working equation. Tangent theta is equal to 5 over x. So we will be getting the derivative of this equation implicitly with respect to time. So the derivative of tangent of theta is secant squared of theta, and then we write d theta over dt. For 5 over x, we know that this is the same as 5x raised to negative 1. So the derivative would be negative 5 x raised to negative 1 minus 1 or negative 2, and then we write dx over dt. Okay, so continuing, let us just rewrite this. We have secant squared d theta over dt is equal to negative 5 over x squared times dx over dt. Now, since we are looking for d theta over dt, we need to divide both sides of this equation by secant squared. So we have d theta over dt is now negative 5, is now equal to negative 5 over x squared times dx over dt all over secant squared of theta. And we know that 1 over secant squared of theta is also cosine of theta. Or 1 over secant squared of theta is also cosine squared of theta. So we write negative 5 over x squared times cosine squared of theta times dx over dt. Okay? Now, um, since we are given the value of the angle, and that would be 30, 60, and 75. So the values of the angles that we need to use would be 30 degrees, 60 degrees, and 75 degrees. And we know that dx over dt is negative 600 miles per hour. Now, the only unknown in our resulting equation is the value of x. So we can get the value of x by using again the relationship in the triangle. So here we have 5. This is x, and this is theta, the angle of elevation. So again, using tangent of theta is equal to 5 over x. We find that x, when we solve for x, we have x is equal to 5 over the tangent of theta. So we will just substitute the values of theta, meaning 30, 60, and 75, and we will get the corresponding values for x. So let us do that. So at theta equals 30 degrees, we will find that the value of x at this angle is 5 square root of 3. So this is in miles. At theta equals 60 degrees, the value of x is 5 square root of 3 over 3 miles. And then when theta is 75 degrees, we get that x is 10 minus 5 square root of 3 miles. Okay, so how did we get this? You simply substituted 30, 60, and then 75 to theta in in this equation. Okay, but make sure when you solve for x using the equation x equals 5 over tangent theta, you have to make sure that that your calculator is in the degree mode, because you are going to substitute angles that are expressed in degrees. Okay, now since we know the values of x, and we are already given the values of theta, we can now proceed with getting d theta over dt. So at theta equals 30 degrees, we have to substitute the value of x and theta. We have negative 5 over the value of x is 5 square root of 3. We square that, and then times cosine of 30 degrees and then squared. And finally, we have negative 600 miles per hour. So computing this gives us the value of d theta over dt when theta is 30 degrees, and the answer is 30, and the unit will be degrees per hour, or you can write it as 30 degrees per hour. So our interpretation for this one would be the angle of elevation increases, because the answer is positive, increases by 30 degrees every hour at the instance when theta is 30 degrees. Okay, so this is our answer for d theta over dt when the angle is 30 degrees. Now, using the same procedure, I will not show the substitution anymore, but you will find that at theta equals 60 degrees, d theta over dt is positive 90 degrees per hour. And at theta equals 75 degrees, d theta over dt is 111.96 degrees per hour. So that is the solution for the given problem.